Hey everyone, and welcome to The Explainer. Today, we are diving into something truly fascinating. We're looking at an exceptionally well-designed 6th grade science mission called the Algae Bloom. It basically takes this typically dry academic concept, correlation versus causation, and turns the whole thing into a captivating real-world mystery.
Find what's really killing the fish with the data, not the rumor. That single sentence is the guiding mantra for this entire $19 three-day curriculum. It sets the stage right out of the gate. Students aren't just sitting there memorizing facts. They're actively stepping into the shoes of a water science investigative team. They've got a real problem to solve, and they have to use data to actually do it.
So here is our mission briefing for today. We're going to start with Section 1, a pond murder mystery. Then Section 2 covers Day 1, following the data. Next up is Section 3, Day 2, proving the cause. Section 4 tackles Day 3, fixing the source, and finally, Section 5 looks at assessing the student mission. Let's get right into it. Section 1, a pond murder mystery. Let's set the scene.
Okay, so the situation handed to the student science team is incredibly urgent. The school pond's fish are dying, and right away, human nature takes over, right? There's this loud, persistent rumor pointing the fingers squarely at a factory upstream. I mean, it's the obvious villain. But the mission immediately asks the students to just hold on a second. To actually crack the case, the students are given one absolutely crucial piece of biological context. The fish in this pond need at least 4 milligrams per liter of dissolved oxygen to survive. This is brilliant because it establishes a hard, scientific baseline for their investigation. They aren't looking for some mysterious poison, they are looking for where the oxygen is disappearing. Which brings us to Section 2, Day 1, following the data. Correlation versus rumor. The curriculum immediately challenges the kids with this direct question. It completely forces them to stop, pause all the wild accusations, and actually test the rumor against hard numbers. They have to ask themselves if the loudest voice in the room actually has the facts straight. And to answer that, they're presented with a data table containing specific measurements from 3 different spots in the pond. They're tracking dissolved oxygen, nitrate from fertilizer, and the amount of algae present. So right away, this is teaching them how to juggle multiple variables at once. And wow, the results are a massive plot twist. The factory spot? It actually has perfectly healthy oxygen levels at 7.5 milligrams per liter, which is way above the required 4.0. But the school field's runoff spot, it's sitting at a deadly 2.0 milligrams per liter, coupled with high fertilizer nitrates and heavy algae. The rumor was completely wrong. As the Day 1 answer key highlights, the students have successfully identified a strong correlation. The low oxygen happens to be exactly where the fertilizer runoff and heavy algae are. The explicit lesson here is so profound. Follow the data to where the problem actually is, and whatever you do, don't just convict the loudest suspect. Section 3, Day 2, proving the cause. Moving beyond correlation. Now, as any good scientist knows, a pattern is not proof. Just because the fertilizer and the low oxygen are hanging out in the same place doesn't mean one caused the other. To prove the fertilizer is the real killer, the lesson introduces this vital concept, a controlled experiment. This is a massive standard in middle school science. Students learn that you have to change only one variable, in this case the fertilizer, and keep absolutely everything else, like light, temperature, and water, exactly the same. And the results of that controlled test are striking. The students look at data from 3 jars that were kept in identical conditions for 5 days. Jar A had 0 fertilizer and kept a super healthy 6.8 milligrams of oxygen. Jar B had just a little fertilizer and dropped to 4.5. But Jar C, it got a lot of fertilizer and the oxygen absolutely plummeted down to a lethal 1.8. The crucial takeaway here is this. Because only the fertilizer changed, this exercise successfully transitions the students from a simple correlation to confirmed cause and effect. They have finally proven the mechanical cause behind the dying fish. More fertilizer causes more algae, which ultimately causes that massive oxygen drop. Moving on to Section 4, Day 3, fixing the source. Choosing the right solution. Now that they know the cause, students are presented with a few potential solutions, and they have to evaluate them carefully. On one hand, option C suggests just dumping a bunch of algae-killing chemicals straight into the pond, but the lesson forces them to realize this is only attacking the symptom, and honestly, it might even harm the fish further. The much better choices involve planting a buffer strip or just using less fertilizer in the first place, because these reduce the runoff right at its source.
So the lesson heavily reinforces that the best environmental solutions must target the exact root cause proven by the evidence. You don't shut down the factory because, hey, it's innocent. You don't just temporarily mask the issue with chemicals. You stop the fertilizer runoff. That's how you fix it.
Section 5. Assessing the student mission. Grading reasoning, not guessing.
First off, I really want to point out how thoughtfully designed this is. The curriculum smartly provides scaffolded versions of the student pages, complete with hints on how to read the data tables and even sentence frames for support. This ensures that literally all learners, regardless of their reading level, can jump in and participate in this high-level scientific reasoning. The thinking remains rigorous, but the barriers to expressing it are completely lowered.
When it comes to the actual grading, the assessment rubric explicitly focuses on these core areas. It grades how well students analyze the data, how well they distinguish correlation from causation, whether they actually target the root cause, and how they explain their choices with evidence. It totally removes the pressure of just blindly guessing a single right villain, and instead it rewards the scientific process itself. The entire 3-day experience culminates in this rigorous capstone reflection prompt. It challenges students to synthesize their whole journey. They literally have to articulate how they moved from investigating a rumor to finding a correlation to proving causation with an experiment and finally to designing an actual solution. It is just a masterful way to lock in the learning. Which leaves us with an incredibly powerful thought to end on. We've just walked through a curriculum designed to teach 12-year-olds how to look past loud rumors, differentiate between coincidence and cause, and treat root issues instead of just masking symptoms. If 6th graders can learn to hold themselves to this standard of evidence-based problem solving, shouldn't we demand that exact same rigor in our everyday lives, our news, and our own decision-making? Think about it. Thanks for joining me today, and I'll see you next time.